So we will look at probability. So probability is basically a chance of something happening. Now there are different kinds of probabilities. Mostly we are going to be looking at classical probability. So if you look at classical probability, these usually have like a finite set of possibilities. So if I have a dice, there's a finite set of possibilities. I have 6 possibilities, and I can talk about what is the chance that I'll get a 1. Okay, and then I say, well, there are 6 sides, there are 6 different numbers, only one of them is a 1, so the chance of getting a 1 is 1 out of 6. So this is the kind of probability that we usually do, in which you can count the number of total possibilities, which is called a sample space. So you know the sample space, it's finite, and then you basically know what are the events that you want in it, right? So in this case, in the dice, I can get 1, I can get 2, I can get 3, then I can get 4, then opposite of this I can get 5, and I can get 6. So each of this is an event. All these events are possible. Okay, and if I roll the dice and see, this is called a trial. In this trial I got 5. Okay, so we talked about the sample space. So the sample space in this is 1 to 6. Okay, so and each of these is the event. Any of these events are possible. So when if I roll the dice and I got 5, then I got 2, then I got 4, then in the trial 1 I got 5, trial 2 I got 2, trial 3 I got 4. So these are called trials. So here if I talk about what is the event of getting an even number, right? So the even numbers are 2, 4 and 6. There are 3 possibilities. There are total 6 possibilities. So here I say, the chance of getting, the probability of getting an even number is basically 3 out of 6, which is half. Half the chance of getting an even number, half the chance of not getting an even number. So essentially in this classical probability, we take a ratio of what I want versus all the possibilities. Usually all the possibilities are finite, and they are not continuous possibilities, they are discrete possibilities. So I can count them also. So for example, if I was talking about what will be the temperature tomorrow, that's not a discrete value. It can be 33.2473. I mean, I don't know exactly how many digits you want. Depending on how many digits you want, it will be continuous, right? So if you are talking about any measurement in which there are number of sides of a cube or number of sides, these are discrete. You can count them very clearly. But if it's a continuous number, then you can't count it. That's all. Yeah? So if you look at this dice, right, and I say what is the probability of getting orange. Now in this case there are 2 oranges. Unlike the dice in which there was only 1, there are 2 oranges, there are 2 greens, and there are 2 oranges, 2 greens and 2 pinks. So the probability of getting an orange is, there are 2 possibilities out of the 6 possible possibilities. So it's 2 out of 6, which is 1/3. So in this case, unlike there which was 1/6 of each of them, here even getting orange, because there are 2 sides that can give you orange, you get 1/3 by this. So if you talk about an event such where if I roll this dice, not the other one, this dice, I'll get less than or equal to 6. Now all of them will give you less than or equal to 6. So this is called a certainty. So this is a certain event, right? This event is certain, it will happen. And similarly, if I ask for what is the possibility that from this dice if I roll I'm going to get a 7, that's an impossible event, right? So this is a certain event, that's an impossible event. Then we talked here about if I get an even, what's the possibility? If I get something that's not even. Now these are the only 2 things together, right? Together, and they are, if this comes, this won't come, if this comes, this won't come. So these are called mutually exclusive events, right? Another example, I want to get probability of 4, I want to get probability of 5. If I get 4, I won't get 5. If I get 5, I won't get 4. So these are also mutually exclusive events. So if I take all possible events, when I am doing something, if I take all possible events, then all possible events together, for example, if I take in that I get 1, I get 2, I get 3, I get 4, I get 5, and so on. If I exhaust all the possibilities, that's called an exhaustive event, which means you have included everything. Of course, it will have all these things. Yeah. And then, as we have done in sets, right? We have in the set language we talk about A and the complement of A. So if you remember A, if you treat this as a set, and we take anything here, if we take these two and say that is a set, then this will be the complement of A, because this is the full subspace. So it's like A and A complement. So this part stays the same, that you will have complementary events. If you have any event, you will have all the other events that are possible, calling it a complementary event.